So here's some suggestions for designing our experiments, maybe traps to avoid. These are, we probably won't find these in a textbook. These are some characteristics or some suggestions that I have learned over many years of doing research. Firstly, we should always randomize the allocation of treatment to plots. Later in this lecture, we'll learn about methods for making that random allocation. We shouldn't make assignments ourselves. We are implicitly biased so that we should use a randomization protocol rather than an arbitrary allocation. Once we've made our randomization, we should check for the chance plot arrangements. The example in the textbook, we'll look at this in more detail next week, but we should just eyeball that, say, treatment 1 is distributed uniformly through the experimental space. And if, even though we may have used a randomized protocol, we still may have a chance arrangement of some treatments together. And if we have reason to suspect we don't have a good experimental design, we can just discard that and make a new design. As much as possible, we should try to use uniform experimental material. We should be careful in selecting our research sites. We should try to avoid patchy field sites. We should try to avoid gradients in the greenhouse. We should avoid planting our studies too close to trees where we may have a gradient in wind speed or temperature. We should try to avoid areas with known fertility gradients or an uneven field history. Maybe the prior year had different treatments, and we should, as much as possible, try to find as uniform a site as possible. Often as graduate students, we might not have been around to know what the history of an experimental area is. And so we should use resources such as the research station managers. They will be aware of the history of those experimental areas. We should try to avoid any bias in sampling. We should sample plots in order of the layout. It may be tempting to want to sample, say, all of treatment 1 and go to the locations where treatment 1, if it maybe has a specific protocol sample. But we should be very careful to avoid sampling in the treatment order. We should sample in the plot order. They will be randomized, and so then our sampling will be randomized. If we do have a bias, say we become fatigued and sample later plots less carefully, or maybe there's say we're sampling outside and we can see that there's, say, some rainy weather coming. Maybe we accelerate our sampling protocol to try to get done before it gets, before the bad weather comes. And we may end up being less careful sampling later in the experiment due to having to rush so that we could get done. So we should stick to the order of the layout, sample in that order, and if we do have a bias, then it's going to be occur randomly for the treatments if we follow the plot layout. We should avoid using the plot map when we're sampling. There's an implicit bias that if we are looking at the treatments, we may be biased to favoring some treatments rather than others. And if we're looking, say we're counting insects and we count some treatments with more carefully than other treatments, Maybe we anticipate, say, treatment 3 should get a different result than treatment 2. We may spend more time on treatment 3 if we know what those plots are. So we should just sample them all without reference to the plot map to avoid subconscious bias that can occur in our sampling protocol. Equally, when we're applying treatment, say we're applying fertilizer, it's better to, if we've weighed our fertilizer into bags, we should put those bags out on the plots and spread that in the plot order of the layout. It might be tempting if we have, say, we're spreading we have one fertilizer treatment, and we could go around and distribute all of fertilizer A first, come back, do all of fertilizer B. But we run the risk of bias in that those treatments are not being applied in random order, they're being applied in the treatment order. If we did have bias, say it started raining halfway through the experiment, then some of the treatments would be spread, and we'd end up having to spread all of one treatment after the rain rather than before the rain, may introduce bias. We should try to avoid uneven site management. If we're spreading fertilizer, it may be tempted to drive past the experiment and spread fertilizer over the study. Those fertilizer trucks may not spread equally. And so we may end up with an uneven distribution of fertilizer. Similarly, irrigation, if we put the irrigation spigot on one side of the study, it may not irrigate uniformly. And so we should use management options that apply those treatments uniformly across our study and avoid the possibility for uneven application of those management effects. We'll come to measurement methods, but we should avoid measurements that have a lot of similar values. If we say doing a germination study and half of our experiment has 100% germination and then other treatments have less than 100%, the difficulty we have when we have a lot of numbers of the same values, maybe it's a lot of zeros, a lot of hundreds, is that when we have a lot of values the same, there is no variation in those, and that when there's no variation, some plots have variation, some plots with similar values have no variation. It may invalidate our analysis of variance. We'll come back to this point later when we're looking at some of the implicit assumptions in our methodologies. We should use border plots to minimize edge effects. I'll talk about this a little bit more detail in a minute. For those of you working in lab, when you're making using lab duplicates, are used to show consistency of a particular method. In this case, we had a study looking at DNA fragmentation, and plant material should be was harvested separately for lanes 2 and 3. So we repeated our experimental protocols right from the beginning. So we took 2 separate samples from the same plant to measure the consistency of our experimental protocol. We can see lanes 2 and 3 have the same banding patterns. Lanes 4 and 5 were from the same plant and processed as experimental duplicates. Similarly, lanes 7 and 8 and lanes 9 and 10, we can see those consistency of banding patterns.